you're going to pause the video and try evaluating the sine of 2a and the cosine of 2a when you're given that the cosine of a is 4/5 and a is between 0 and pi over 2 inclusive. And here are the double angle identities that we looked at in example 1 that you can use as a reference. Once you've given these two problems a try, then go ahead and turn the video back on and we'll work through them together so you can check your answers. Okay, so the sine of 2a using our double angle identity 2 sine of x cosine of x, that means we're going to need to know the sine of angle A given the cosine of angle A, and that requires a Pythagorean identity. So if we know that sine squared A plus cosine squared A is equal to 1 using the Pythagorean identity, and we're given the cosine of A, and we know that that's in quadrant 1 where everything is positive, then solving our Pythagorean identity for the sine of A, we would subtract the cosine squared A from 1 and then square root both sides, but instead of a plus or minus, since we're in quadrant 1, we're going to keep the plus. So that's going to be 1 minus the cosine squared of A, and we were given that cosine of A is 4/5. So we'll substitute that in for the cosine of A and then square it. Okay, then we can go ahead and use our double angle identity for sine, which is 2 times the sine of the angle, and the sine of A we just found is the positive square root of 1 minus 4/5 quantity squared, and that gets multiplied times the cosine of the angle, and that's given as 4/5. So we're taking 2 times, and then 4/5 quantity squared is 16 over 25. So we're going to need to know the square root of the quantity 25 over 25 minus 16 over 25, which is 9 over 25, and the square root of 9 is 3, and the square root of 25 is 5. So the sine of A is 3/5. Then that's multiplied times 4/5. And then we'll have 2 times 3, which is 6, times 4, which is 24, divided by 5 times 5, which is 25. And the sine of 2 times angle A is going to be 24 over 25. Okay, next we're going to evaluate the cosine of 2 times the angle, and we know the cosine of A, which was given, is 4/5. So I'm going to go ahead and use this identity. But since we know the sine of A is 3/5, you could also use cosine squared x minus sine squared x, or 1 minus 2 sine squared x. But I'm going to go ahead and use the given. So that's 2 times the cosine squared x. So I substitute 4/5 for the cosine, and then I'm going to square that, and that's minus 1. So we have 2 times 16 over 25 minus, and then we need a common denominator, so that's going to be a 25 over 25. 2 times 16 is 32. And then 32 minus 25 is 7. And so the cosine of 2a is 7 over 25.